Okay, the final Excel lab for week 2. We're going to do some normal probability questions. So we already did these examples in the lecture notes. So if some of this is confusing, you might find it helpful to just go back and check the notes we did in our handwritten notes. So we're going to calculate, let's start with the standard normal distribution. Recall that the standard normal distribution has a mean of 0 and a standard deviation of 1. So maybe I should be a little more clear. Let me say mean equals 0, standard deviation equal to 1. Okay, we want to find the probability that z is less than negative 3. So we're going to use this function. It's going to be norm.dist. So we'll do, it's going to be the x value, and then the mean, and then the standard deviation, and then we're going to say true. Okay, so this is the formula we're going to use. So we're going to put our x value, then the mean, then the standard deviation, and then write true. So let's first note something, which is just that the norm.dist function only provides probabilities in the form of the probability of like x less than x. So that's going to be convenient here for these first two examples because we're already in that form. It's already z less than some value. And don't worry about the fact that I'm using x and z here. It doesn't matter. The letters are just placeholders. So let's go ahead and try this function out. So we want the probability that z is less than negative 3. So we're going to use this norm.dist function. Let me maybe move this over a little bit. So let's do equals norm.dist, open parenthesis. So we want less than negative 3. So I'm going to say negative 3, comma, our mean is what? 0, comma, standard deviation is 1, comma, and then we want to write true. Close parenthesis, click enter. We get 0.0013. So again, if you go back to the lecture notes, you'll see that we got something just like this. So now let's do the same thing, except for positive 3. So let's do equals norm.dist, open parenthesis. So now we want to do positive 3, comma, mean here is 0, comma, standard deviation is 1, comma, true. Close parenthesis, enter. We get 0.9987. Okay, so now we want the probability that z is between negative 3 and 3. So one way to do that is just to take the probability z is less than 3 and subtract off z less than negative 3. Again, if this is confusing, go back to the lecture notes to see why we do this. So let's do equals this value minus this value. So C6 minus C3. And then let's say we want z bigger than 3. Well, if this function is only going to give us probabilities in the form of x less than or some value, then if we want greater than, we could just do 1 minus that value. So what if we do equals 1 minus norm.dist, positive 3, comma, 0, comma, 1, comma, true. Close parenthesis, enter. So just notice that if we do equals 1 minus z less than 3, we're going to get 0.0013 as well. Or just note that the probability z is less than negative 3 is the same as probability of z bigger than 3, because we know that the normal distribution is symmetric, and so we expect those to be the same. Okay, now let's do the normal distribution with an x with a mean of 10, a variance of 4, or a standard deviation of 2. So let me write this as mean equal 10, standard deviation equal 2. And we're just going to do the same thing. So we have x less than 14. So I'm going to say equals norm.dist. So now what was our 14? Okay, equals norm.dist dist. So our x value here was 14, comma, what's our mean here? Well, our mean here is now 10, so I'm going to write 10, comma, standard deviation is now 2, so I'm going to write 2, comma, true. Enter. Okay, x is between 8 and 12. So remember that like up here with -3 and 3, we had to do the probability z less than 3, subtract off z less than -3. So let's just do that all in one go here. So we're going to do the probability that x is less than 12 minus the probability x is less than 8. So let's write this as equals probability, or sorry, this is equals norm dot dist. So we're doing 12, comma, mean is 10, comma, standard deviation is 2, comma, true, close parenthesis. But now we want to subtract off x less than 8. So I'm going to do minus norm dot dist, open parentheses. So now instead of 12, I'm going to write 8, comma, mean is 10, comma, standard deviation 2, comma, true. Close parenthesis, enter. Okay, and then x greater than 16. So again, this is like this situation where we need to do 1 minus the probability x is less than 16. So let's do equals 1 minus norm dot dist 16, comma, mean 10, comma, standard deviation 2, comma, true, and parenthesis, enter. And if you look at the filled out lecture notes, you can see that I do have all of these typed out if you are confused about how we just did all of that. Okay. So now let's do an example with SAT. Recall we did a problem with SAT scores. So let x be SAT scores. Assume that the SAT scores are normally distributed. The mean of the scores is 1050 and the standard deviation is 180. So that means x is distributed, normal, mean 1050, and standard deviation of 180, so variance is 180 squared. So I'm just going to rewrite this down here. So mu here is 1050, sigma is 180. So step 1, we want to create the empirical rule. Well, recall that the empirical rule is mu minus 1, 2, or 3 standard deviations, and mu plus 1, 2, or 3 standard deviations. So let's start with k. So we want 1, 2, and 3 standard deviations away from the mean. And we know that 68% of the distribution falls between 1 standard deviation of the mean. So let's go ahead and just plug in this formula right here. So let's do equals mu. So mu here is 1050 minus, we just want 1k, so times k, times sigma, which is 180 right here. Enter. Now let's do it for, this is the exact same thing, but now using plus. So let's do equals mu plus k, this is 1, times sigma 180. Enter. And we get the range for 1 standard deviation from the mean. So if you want, we can lock the mean. We don't want these numbers to change. The only thing we want to change is k now. So if we want, we could lock these two numbers in place. So what I might do is I'm going to lock C33 and C34 in place. And remember, we do that with the $sign. So I'm going to say put a $sign in front of C and a $sign in front of 33. And then I'm going to put a $sign in front of C and a $sign in front of 34. And click enter. Because now I can pull this down and keep that formula the same. So if we look up here, if you keep your attention up here, as I hit enter, the only thing that's changing is that G number, because G is coming from over here, 1, 2, and 3 standard deviations from the mean. Notice that C33 and C34 do not change as I cycle between these numbers, because we don't want the mean and standard deviation changing. So let me do that for this as well. So I'm going to lock the mean and standard deviation in place. And then once I do that, I can pull this down. And we have our ranges. So according to the empirical rule, 68% of the distribution falls within one standard deviation of the mean, so 870 to 1230. 95% of the distribution falls between 690, 1410, and 99.7% of the distribution falls between 510 and 1590, which is 3 standard deviations from the mean. And notice that these intervals are getting wider as we multiply by more and more standard deviations. Okay, so what percentage of people would we expect to score between 1050 and 1410? Okay, well, let's convert this into math language. Let's say the probability that x is between 1050 and 1410. So let's go ahead and do equals norm.dist. So first we want to do the bigger number, so 1410, comma, mean is 1050, comma, standard deviation 180, comma, true, close parenthesis, and then subtract norm.dist. But now we want the smaller number, so 1050, so 1050, comma, mean is 1050, comma, standard deviation 180, comma, true, close parenthesis, and enter. We get 47.7. Again, we did all of this in the handwritten notes, and so if some of these things are confusing, please go back and review those. And that is pretty much everything we need to know for Excel in week 2.